Alright, hello everybody. Sorry I'm not at school today. I'm not feeling not good. I'm under the weather, so hopefully I'll be back tomorrow. We're moving on here to 4-5B with the C and D shift like we talked about. Your homework tonight's just going to be worksheet 1, the 6 problems, and then we'll move on to graphs from there. So we've already done A and B, which is the amplitude and period. Or B is associated with the period. Now we're moving on to translations which are horizontal and vertical shifts. So if you look at right up here for horizontal, we know like if we have f of x equals x minus 2 squared, that's a parabola that's been 2 to the right. Spider-Man rules. Same thing applies for an f of x sine x function if we have a minus pi over 2 on the inside, and why is it pi over 2 and not 2 or a whole number? Well, we're going to have shifts in terms of radians. So we would shift this pi over 2 units to the right. So how do we work on graphing that? That's how we'll proceed after we talk about the vertical shift here. Next we have a vertical shift. We know it's a plus minus on the outside. So here it's an x squared plus 2, so that moved the graph up 2. So if we had a function f of x cosine x, and think about that cosine x in parentheses plus 1, that plus 1 is moving the graph up one unit. And note the addition, subtraction of a term on the outside is going to be a whole number, and we'll see why. Typically, that's what it'll be. Okay, synthesizing it all, this is our final form for a sine or cosine wave, where A is your amplitude, B determines a period. Note B is factored out here, so if it's not factored out, you have to factor it out to get the correct B and C, and then plus D on the outside. We're not going to talk about why it has to be factored out. We could simply do an input-output table to confirm that, but that is true that the B has to be factored out to have the correct B value as well as the correct C value. Lastly, back to our even and odd identities. Sine negative x is equal to negative sine x, and cosine negative x is equal to positive cosine x. So if you have this negative B value here, you can simply take that negative on the outside. In cosine, we just cancel it. Really quick, I'll just show the sign. Y is sine. If you look, if I graph it, and then I graph it into that quadrant, if you look, its origin is the first point on the graph, but more importantly, if you look here, that here to here, that's reflected about the origin. Same here to here. So sine is an odd function, and that's why we have that negative on the outside. If we did the same for cosine, we'd see it's an even function. Alright, so first one here, we're going to list all of our A, B, C, and D. First off, we need to factor out the 3. So we are in the correct form. So we factor out the 3. We have x plus, and you put a 3 in the denominator. Whatever you factor out in the numerator, you have to put that in the denominator. Imagine just plugging or distributing the 3 back in. It would cancel. So looking at that, A is 1, coefficient of cosine. B is 3. So that gives us a period of 2 pi over 3. And then we're going to do something else here in a second. And then we have pi over 3, and I prefer to use arrows, so it's plus pi over 3, so we're shifting to the left pi over 3, and then D is 0. So the first thing we're going to do is figure out what a fourth of the period is. And why is that? Because, quickly demonstrate down here, if here's like our basic sine wave, our key points at each of these are 1/4 of the whole period. 1, 2, 3, 4. So when we have this horizontal shift, given the fact that we aren't starting at the y-axis anymore, we're going to be starting over here, for instance, we can't do what we did before, which is go all the way, halfway, and then count up, because we're not, when we did that, let's say our period was 2 pi, we found this midway point, and that midway point was relative to the y-axis. Now if we're starting over here, it's going to be a lot more difficult to calculate that, find the end of the period, then divide in half. The easier way, and I'll talk more about this tomorrow to demonstrate, is just to find out what your step is, or your interval, what this down here, how far you're going from here to here to here to here to here. So the way we do that is simply take that and divide by 4. I like calling it INT. So I take 2 pi over 3 and divide by 4, or same as multiplying by 1/4. And that is going, if we reduce that, that's going to give us a pi over 6. So we are starting at pi over 3, but the interval, how much we're going up, is pi over 6. So I think it would be best if we did each of these intervals, because that's how much the function is increasing stepwise from one key point to the next. So I'm going to make this negative pi over 6, because we're going to the left. And then the next one right here is negative 2 pi over 6, which reduces to negative pi over 3. And that, in fact, will be our starting point of pi over 3. So we need 5 points altogether. We have 1, 2, 3, 4, 5. So this one's 0. This is pi over 6, and this is pi over 3. And again, remember, we're only graphing one period of the function. Our amplitude's 1, so we're only going up and down 1. My suggestion is drawing a dotted line now of where we're starting, and even for the horizontal axis, the midline of the function. In this case, it doesn't matter much because it's on the x-axis, but when we have a shift up or down, that will definitely help. So now we can think of this as our new origin after it's been shifted. Again, we have a cosine, and I probably, even though it's a positive one, it's pretty obvious, I should have put an up arrow. So coming back over here, I'm going to start at the negative pi over 3, because that's my horizontal shift, and it's a cosine graph, and it's a positive one, so I'm going up 1. I forgot to label these 1 and negative 1. And then once we're at that point, our next interval, we go down to the midline, and then down below, up, and then up again. Okay, so let's look at a function when you have all a, b, c, and d. First off, we have this negative here, and sine is a odd function, so we want to take this and move it out front. So I'm going to take that negative and move it out front. I'm going to turn that positive. Our a value is 2 with a down arrow. Remember, you always list it as a positive since it's absolute value. B equals 2. So that's your coefficient right here. So period would be 2 pi over 2, which is pi. And then we want to get our interval, how much we're going up by, because we do have a horizontal shift. And our interval is going to be pi divided by 4, or just pi over 4. We also have a horizontal shift of c of pi over 4, and that will be to the right, and then a d of 1, up 1. Now, it just happens that our interval is the same as the pi over 4, the horizontal shift. Up here, they weren't the same, but they were, the interval was a factor of the horizontal shift. So I'm never gonna give you one that c value in the interval is totally off. At least I don't think so. At least tested wise, you won't be. Okay, so when we do this, we want to go in reverse order. We want to do our d first. When you have all of these, you want to do your d first, but when we do our d, we have to keep a in mind, and then we're going to do our c, and then we also have to keep b in mind while we do that. What does that mean? So 1 is my vertical shift. So let's see, if I go here, I go vertical shift, I put my midline right there. I have to, from there, go up 2 and down 2, because that's my amplitude. Now if I make this this gray line a scale of 1, I'm not going to be able to fit my graph on here. So I'm going to have to shrink down or zoom out my scaling and make this a 1, make this a 2, make this a 3, and this a 4, and then this would be 0. I'm not going to write that. Negative 1, negative 2, negative 3, negative 4. This way I can do a vertical shift up 1, and then I can also do amplitude from there. Now I have to do my horizontal shift, which is pi over 4 to the right, and I'm also going to mark my vertical line at 1. So at 1 I have my dotted line. Try to draw that as best as possible. And I know that my interval is going to be pi over 4. So this first one right here is a positive pi over 4, and that's actually where I'm starting. So I'm going to draw my green line. Sorry, it's kind of hard to do a nice dotted line with the iPad. So now I got to find the next of my points. Well, I got to find the next one here, the next one here. So the way I do that is I know my starting, figure out this next one. I'm sure you might be able to figure it out intuitively, but nonetheless I want to show you how to calculate this. I'm starting off at pi over 4, and I'm adding, I'll go to black here, pi over 4 is where I'm starting, and my interval is pi over 4 as well. It just happens easier to say. I'm going to put a box around that, just so notes wise or visually I see that pi over 4 is because I'm going to add this pi over 4 multiple times. So I'm at pi over 4, I'm adding pi over 4, what would that give us? So pi over 4 plus pi over 4 is 2 pi over 4, which reduces to pi over 2. Again, I want to keep the non-reduced in my head and write down the reduced on paper. So it was 2 pi over 4, I add another pi over 4, that will be 3 pi over 4. And now I'm going to, again, the reason I box this in is when I'm going over here, writing it down, I want my eyes to come back to here. In this case, it really doesn't matter as these are the same, but you're going to have cases where they're not the same like the first one. So writing this out, I think, is important and also helps you make sure you do your calculations correctly. So another pi over 4 plus 3 pi over 4 is 4 pi over 4, which is pi. And I need 5 of them, or I'm starting here, so 1, 2, 3, 4, 5. I need one more. 4 pi over 4 plus pi over 4 is 5 pi over 4. And now I'm ready to graph. So it's a sine function, and the amplitude is 2, and we're going down first. So here's my new origin. That's where I am starting my sine wave, and I'm going to go down first. So remember, this is our interval. So here, now we're going to go down 2. So down 2 relative to positive 1 is negative 1. Then we go back up to the midline, and then we go back up to 3, and then back down to the midline. Okay, good luck with worksheet 1, and I'll see you all back tomorrow.